Hello, and thank you for joining us. Today's webinar is Simply Solving Workplace Challenges, presented by Jacob Harrington, Automation Product Manager for Teledyne CETAC. This webinar is being recorded and will be available within a few days. Okay, now I'm going to turn it over to our presenter, Jacob Harrington.
All right. Thank you for that short introduction. I'm grateful to have the opportunity to today ways that we can work together to solve some current and growing workplace challenges. So before we dive into it, I kind of want to start it just by asking a question and discussing why we're giving this webinar in the first place. The reason that I wanted to give this webinar and talk on this topic is because I want to discuss some of the growing challenges within laboratories, because I think it's important that lab managers hear that they're not the only ones facing these kinds of trials and in their workplaces, and also because better automation can streamline our laboratory workflows. It can ease some of the current strains on lab personnel and lab management, and because I know labs who are using the system we'll be discussing today to automate some of their processes. And I know that it's improved, we've heard from our users that it's improved their workflows, improved their day-to-day working experience. So I'm excited to share some of that information. So I've been a little vague. What am I talking about when I talk about current laboratory challenges? There are challenges that laboratories always face, but we do have some specific challenges that are kind of coming to the fore right now with our current situation. Some of these are COVID related, some of them are not. But three of the big ones that I know labs are really facing and struggling with currently are pipette tips. They're either not available or their cost has gone way through the roof. There's staffing shortages, and this is a big problem, especially for the larger commercial labs, that they're having trouble just maintaining decent personnel to do the work that needs to be done every day. And also social distancing can become a problem. Most of the laboratories weren't designed or laid out to allow for 6 feet between individuals. And a lot of times they were kind of laid out so you have people potentially standing elbow to elbow doing the sort of sample preparation work, because generally there's not a lot of extra or especially not wasted bench space in our laboratories. And all three of these challenges, they can have a negative impact specifically on sample preparation. So what's so bad about sample preparation? This is something that almost every lab has to do to a certain extent, and there's a lot of different steps depending on what market you're in and the needs of your specific samples and getting them prepared for analysis. And what's so bad about it? Well, for the analyst, the sample preparation step is quite frequently the worst part of an analyst's day, right? It's repetitive motions. They're decapping, they're transferring, they're pouring, they're pipetting, they're moving liquid from one place to another place. And sometimes that's following a specific SOP that you do over and over and over again. It seems like it takes all day. In some labs, it actually does. Some places that they'll have sample prep chemists or technicians that all they do all day long is prepare samples, whether it's digests or dilutions or filtering, etc. This sort of repetitive work leads to really low job satisfaction, which in turn leads to high turnover. And it's generally really boring. And it leads your analysts to ask themselves, is this why I became a chemist? I know for me personally, when I finished my degree in biochemistry, the first job that I got out of college was as a QA chemist. And I wasn't even a month into that job. And I looked around and I thought, I've learned everything there is to learn, right? I've mastered all the skills, these 6 repetitive tasks that we did every single day. These long draining shifts where you do the same work over and over and over again. It's important work, it needed done, but it was mentally difficult. And I think there's a lot of analysts and technicians that really struggle with the nature of the work they're being asked to do. For the lab manager, the nature of that kind of repetitive work leads to mistakes, right? Those mistakes, and that's just the nature of it. By doing the same thing over and over and over and over again, it's really easy to accidentally pour liquid into the wrong tube, to accidentally get the tubes moved over to the wrong place in the rack. Or, I mean, I think the biggest thing for me is when you're pipetting, right? You're dispensing. It's so simple to accidentally push that plunger down when the pipette either isn't in the right position, or is over the wrong tube because your mind just wandered for a second. And that sort of repetitive, those mistakes, they can take QC time, right? Sometimes they get, you don't always catch them right away. Sometimes they get into the actual samples being run. And depending on what the mistake is, that may result in rerunning a couple samples, and may result in rerunning an entire batch of samples, which all of that then requires that you go back to the previous step to do more sample preparation, and it becomes very time consuming. And maybe that doesn't happen much. Maybe you've got great technicians or great analysts that don't make a lot of mistakes. That's awesome. But even the best analysts, they get sick, they take leave, they go on vacation, they have their Fridays and their Mondays, you know. Even the best analysts, you know, they're not always going to be there, right? And even if you have a great analyst, then do you really want to pay your great analyst to stand in one place all day long and do the same repetitive motions, right? All of that leads to high staff turnover, which becomes a major problem. It's certainly a big problem right now, but it's been an existing issue for many commercial labs and other labs where it can be hard to keep staff in these unfulfilling roles. And lastly, I think this is kind of a critical question of who made the standards. I've been in, I don't know how many labs where there were specific rules about who was allowed to or not allowed to make the standards. And, you know, if you put your run on the analyzer and your cal curve doesn't pass, or it's not, you know, the QC check won't come in right, the question is never, maybe there's something wrong with the analyzer, right? You don't even look at the analyzer, you look at the sample prep. It's always sample prep, right? That's where the error is almost always located, is in your sample preparation. And it becomes this question, well, who made the standards? Oh, well, Johnny made them. Oh man, Johnny's not supposed to make these. I've been in labs where, you know, the head chemists or somebody, they hear, oh, that guy made them, and they say, oh, just immediately remake them. We're not even going to try and use the standards he prepared. It's not worth the time, right? So you can get around that by trying to use your best analysts and siloing people into specific roles, but it becomes burdensome for the entire lab. And again, that leads to re-preparation, which is more time. And you only have so many hours in a day. It hurts your overall efficiency and your overall lab. Lastly, I want to touch on this. This is something that I was told by a lab manager several years ago. It's always stuck with me since, and I think it's really critical, is that every manual step is an opportunity for error. Every time you have a human transfer liquid from one place to another, every time you have them transfer a tube or a bottle, anytime you've got a person touching and moving something, it becomes an opportunity for error. And the more that you can automate that, the less errors you have in your overall workflow. So with all that in mind, I want to introduce the SimPrep sample dilution or sample liquid handling system. What this is it's based on CETAC automation. So the picture you see here, the main eye-catching piece right in the center is the ASX 560 Autosampler. This is the most commonly sold ICP or ICP-MS autosampler in the world. It's incredibly popular. It's built on CETAC's 30-year history of making automation for ICP and ICP-MS work, which means it's designed to and has a history of working with aqueous and acidic samples. So we took that autosampler that's known for long lifetime and ease of use and combined it with a Hamilton micro station. So Hamilton normally presents their little box as semi-automated sample preparation, meaning that it can do You can program it to do some nice prep for you, but you still have to have a person stand there and hold the other end of the line to get the liquid into the tubes. So by combining the two together, we went from semi-automated to a fully automated sample preparation system. You use the same sample racks that you would use on your ICP Autosampler, right? So you prep and then you can transfer them over for analysis. It's got an easy to use software. It's a small footprint that can be mobile. I mean, you could put this all together on a cart with a laptop. You can do full sample homogenization, and it's really designed for any aqueous samples, anything from soils to mining, drinking wastewaters, haze and feeds. I mean, there's a lot of applications where this can provide some sample preparation relief. So here we're going to watch a really short video that just kind of lays out what the system is and shows it in operation so you get a sense of how it works. So the very first thing that it does is it'll go into the rinse station and it cleans out the probe prior to beginning the sequence. And this ensures that everything's clean. It also ensures that you have fresh diluent in your line. Next, the sample aliquot is drawn. These are coolant samples, which is why they look a little different. And then your diluent's drawn. So you'll notice the smaller syringe on the right is used for all the sample movements, sample handling. The larger syringe on the left is used to control the diluent movement. By using two syringes together, you're able to get a larger linear dynamic range for your dilutions. You can do something like a 1 to 1,000 dilution in a single step with good accuracy in an automated fashion, which you wouldn't be able to do with a single syringe handling all the work. And then you just repeat it, right? Pull up your aliquot, diluent, put them together in the tube. And then you go rinse. It'll automatically rinse between each sample. And every step in here is programmable. So if you want to optimize your method to really dive into and optimize performance, you can do that. All right. Now I'm going to talk mostly about dilution. We talk a lot about dilution. That's kind of the main thing for this system, but that's not all it can do. There's a lot of functionality, and the software leaves it very open to the user. So what else it can do more than dilution? That would be dispensing or dosing. It actually does a really nice job at this, partly because the rinse step between samples is optional. So you can turn that off. It'll go directly from tube to tube to tube, dispensing aliquots of diluent into each. You can do serial dilutions, which is, where it will prep from A to B and then from B to C and potentially C to D, depending on how you program it. You can split samples. This kind of as the example on the right here. That would be you preparing the same sample in multiple different ways. So like a 1 to 10, a 1 to 5, 1 to 100. Those could all be prepared into separate racks, and then the racks can go off to different analyzers. You can spike samples by adding a spike from one of your standard positions. You can do that in a single step while doing the dilution. So you can add your not only your sample aliquot, but also a spike aliquot as well in a single step. And of course, it can prepare your standards. This is a really big feature, as it can prepare the calibration curve in an automated fashion for you. So that's a sense of what it does. Now I want to talk about how well it does it. So we actually were able to obtain a sample from a local source that failed the EPA short-term health advisory for manganese. So they had too much manganese in their drinking water, in their drinking fountains and stuff. Now this was a few years ago when we were drinking out of drinking fountains. But it was to the point they actually had to put up a notice not to use their water for infant formula because it wasn't safe for babies. It was safe for adults, but it was enough that it became a health hazard. So we went out and got some samples from them, and then we used them for an EPA 200.8 application note, which is published on our website. So what you see here is there's two different experiments presented here at the same time. On the left, what we did is we prepared the sample at a 10x dilution 10 times. And we did it two different ways. So we did that by hand, and we also did it automated on the SimPrep. And then the control in the red, what that is actually, that was a single dilution made up in a 50 ml tube, and we just analyzed that same 50 ml tube 10 times. So What you can see here, and the idea was to give us a good control baseline for if the sample preparation was adding variability to the samples, and we would see it. But the RSDs across the board came out pretty much indistinguishable all red at that 0.6 line. So 0.6% RSD across the 10x dilution. I have to say kudos to our analyst. She did a great job preparing those samples to be able to match what the automation can do, but very, very good reproducibility there. On the right is another example where we did the same kind of dilutions, but at 10x, 20x, 50x, and 100x, trying to show different dilution factors. You can see at the higher level dilutions, your RSD goes up a little bit, but it does for both the hand prep and the SimPrep as well. And again, they came out about the same at 0.8% RSD, which is still excellent. We also had the SimPrep prepare calibration curve, and we prepared it by hand as well. So this is a comparison of the two. It was a 6-point calibration curve made from a 100 ppb stock solution, hand prepared via serial dilute, and then both the hand preparation and the SimPrep produce good calibration data, and generally excellent. But what you can see is the gray is the hand prep, and the zinc line obviously stands out as being not one with where we only had 0.997. That's still passing. It's still better than 0.995, but it's obviously kind of the outlier in this set, and that's because on the hand prep somehow we got some contamination into the preparation for zinc, and you can see that here, which did not happen with the automated sample preparation. And this was actually prepared by the same analyst that had done the previous work where you saw the RSDs. So again, this was great analysts, good at their job, but sometimes things can creep in with hand prep. Here's the calibration verification, of course. So we did this to try and show kind of reproducibility of the CCV prep, but also stability over time. So the ICV was a second source from our cal curve. CCV was that same second source. And they were all prepared again at a 1 to 10 dilution. As you can see, we're getting very good reproducibility right where they're supposed to be. Everything's easily within 10%, and almost all of it's within 5. And then lastly, again, this is part of that same EPA 200.8 app note. We got a couple NIST standards, 1640A and 1643F, trace elements in natural and unnatural water. Just trace elements in water and trace elements in natural water. So we prepared these again on the automated system, and we're able to do, it was a 1 to 5 dilution, so we're actually moving 2 mils of raw sample for a total volume of 10. And even with moving that larger aliquot, we're still able to get very, very good recoveries on these. So everything fell between 92 and 103% recovery, even though we had a couple lines like I think it was thallium and silver, where they came in with very low detections, but we're still able to get excellent recoveries. Lastly, we're going to talk about carryover. So this is a big point of concern on the system. It's a question we have come up a lot. So the data presented here is from a study that we did kind of when we launched the product 2.5, 3 years ago. Where what we did is we actually prepared a standard, had the SimPrep prepare a 100 ppm solution at a 10x dilution, and then directly after that, prepare a blank solution at a 10x dilution. Then they were analyzed on the ICP such that our blank was analyzed on the ICP after another blank, so there was no potential contamination on the ICP side. And we essentially compared that blank to our baseline blank for the ICP, and then compared that to the intensities from the prepared standard to get a percent carryover on the run. And as you can see, we're able to get very, very good recoveries. I mean, these are all percentages. So I think the very worst that we got was calcium, which was a 0.02% carryover. But generally across the board, very, very good washout, very clean. And the rinse is programmable, so you can add more or less rinse time to meet the needs of your specific method. We also have a tech note that's published on our website where we had a lab that was concerned less about carryover from sample to sample and more about a systemic contamination. So what they did is they prepared 25 blank solutions by hand and then had the SimPrep dispense 25 blank solutions into tubes. And then they analyzed both on their ICP-MS at their lowest detection level method. And what they found is actually that the SimPrep was cleaner than their hand prep was, kind of across the board. It wasn't a huge margin. They did a good job on their hand prep, but you could tell that the data was actually slightly better on the SimPrep, and there was no visible carryover from any. They were concerned about silicon and boron specifically from the borosilicate syringes, but no carryover was evidenced there at all. So, so that's kind of how it performs. There's a lot of analytical data there, and I know I ran through it fast. I want to talk a little bit about how the software itself works, because obviously the system's really only as good as the software to control it. And I know that in the past there have been some prep systems on the market that were really burdensome to operate. So I want to highlight this as well. The software is, as I mentioned, it's pretty intuitive and fairly easy to use. Partly that's because it mostly feels like an Excel spreadsheet. If you can run an Excel spreadsheet, you can run this software. So what you see here, this picture is kind of the main sequence page where you would spend most of your time in the software. And you can see it's got sample information on the far left. That would be your raw samples. So you specify where those are. If you want to put in the name of your samples, you can, or you can just do something like what I did here and just kind of call it multi-prep. You can give it a name that's specific to the type of preparation that you're doing rather than the individual sample. And then it actually, this is set up to be a fairly complex method where you have, this is what I mentioned before, the idea of kind of same sample multiple ways. For most applications, if you're just doing kind of a one dilution from A to B, you would only use the kind of the sample portion on the far left and then that dilution 1 area. Within that, you basically select where your raw sample is, where you want it to be diluted into, and then what your total, 10 mil or 5 mils, how much sample you want it to put in there. And that can be put in either, as seen here, everything in here is microliters in the picture, but you can also put in like 10% or 1 to 10, and it will run the math for you. And then if desired, you can also add a standard spike. So you can put an aliquot of standard solution, which standard you want to pull from, and how much you want to pull. And that it will always make sure that it pulls the standard before it pulls the sample, to make sure that you maintain the cleanliness and integrity of your standards from sample to sample. And you can actually send it to the rinse to do a quick dip in between movements if desired. So that's kind of the sequence page. Some of the other things you can do to better optimize your method, you can add an air gap. We always recommend that. It'll put an air gap between your diluent and your sample. If you also have a standard spike, it'll put an air gap between the standard and the sample and the diluent, so they all are separated. That prevents the liquids from kind of commingling and just gives a better, truer dispense step. Like I mentioned before, there's full wash cycle control, so you can go, you can tell it to rinse as much as you want between samples. It rinses both the inside and the outside of the probe. Try and get it really clean in the rinse station. If you're doing something like dispensing, you can completely remove the rinse step entirely. Lastly, there is some sample homogenization option, which is, it's a fairly rudimentary mixing step, where what it will do is the probe essentially, after dilution, will go back into the diluted vial. It's a lot of times with aqueous samples, just by dispensing the sample and then the diluent on top of it, you get enough mixing that will work pretty well, and you don't have to do any additional sample homogenization. I also wanted to highlight some of the software's flexibility. So it's designed that you would essentially run the same sequences from day to day. So a lot of time you're going to do repetitive work, and that's really what this is designed to automate, so that your humans don't have to do that repetitive work, right? So doing the same sort of 1 to 10 or 1 to 100 dilution every day, 60 samples at a time, that's very common work. And that's exactly what this is designed to automate. So for that sort of work, I mean, you create your sequence once, and then you just load that file and run it as many times as you need to in a given day or a given week, etc. So it's really nice, and it's really easy to switch back and forth between different methods, and you can optimize things like your rinse protocol and mixing and air gaps to your specific sequence. So you may want to have different settings for your calibration curve preparation than you would for your standard 1 to 10 samples. And you can program them separately and have different specific methods for each. And then it's easy to switch back and forth. But also, the sample list is simple to adapt from day to day. So you're able to select, deselect, and expedite samples, which is kind of this skip, go, express that you see on the right. But essentially, what that allows you to do is, if you have your sequence that already has 60 samples in it, right, that you'd normally just do every day, but then you get to your last rack of the day and you only have 37 samples left, you can select the bottom 23 and click a button to make them, to move them to skip, right? So then that line will just not be processed. Then you can use the exact same sequence file. It's really quick to edit it and change it for the needs of that specific run or that specific day. The other thing I want to highlight is that express, kind of the double green arrow. What that does is you can edit the sequence as it's doing the preparation. So as it's diluting, if you have a hot sample that comes in or a set of them that come in and they need to be run right away, what you can do is kind of go down the list. You can add those on or edit some existing lines, put them in and mark them with that double green arrow. And then what it does is the software will finish the work it's in the middle of, right? Finish the dilution it's doing. Then it will jump ahead to your expedited samples. It will prepare those, or either that one or that set, prepare all of those, and then it will go back to where it was and just pick up right where it left off in its normal preparation. You can grab those samples and take them with you. So that can be really nice if you do have that sort of hot sample that comes in and needs to be run right away, or something that like failed and you need to re-prep it and run it again. That it has the flexibility to allow that to happen easily. So beyond that, of course, there's live progress, so you can tell which sample's currently running, and also if a sample's is all done being prepared, it'll give you a little blue check mark there. And there's a couple, I got like 2 more things for system configurations. We're talking about the SimPrep. One that's really, really popular in kind of lower throughput labs where they don't have the super high throughput need, but may still want the data quality improvement, or may still just want to automate their sample preparation, is that you can set this up so you use 1 autosampler and 2 flow paths. So what I mean is you can have the same autosampler do your sample preparation and also your sample introduction for analysis. So you can switch the software, or switch the autosampler between talking to the ICP and talking to the SimPrep software, and you can use the same computer to do that. It's a fairly basic thing. We've got a little tech note about it on our website, so you can get more information if you're interested. But basically, we use a USB hub, and the USB hub has little push buttons to turn the ports on and off, and that push button allows you to activate or deactivate the USB communication to the autosampler that would talk to the ICP. So it allows you to turn that line on or off. And what this results in is you can push a button to change which software program the autosampler is talking to, either the analysis program or the dilution program. And then once you've changed that communication, you need to make a single liquid tubing change to change the probe to connect to your analyzer rather than your dilution module. So it makes it really, really simple to switch between sample preparation and sample introduction. Lastly, I want to highlight there's different configuration options, and you've seen that in the slides. You've seen SimPrep 560 and the SimPrep 280 in some of these. So You can get this as a 4-rack or a 2-rack version, though the 4-rack is by far the most common. There's also what we have the SimPrep upgrade path. This is particularly nice for labs that already have an Autosampler and just want to add some additional functionality. So this can be used with an existing 560 or 280, but it can also be used with our previous generation of Autosamplers, the ASX 520 and 260. And I've seen a lot of labs where they have an ASX 520 sitting on a shelf or sitting in a closet or somewhere in storage, and the thing works, right? It works great. There's nothing wrong with it. But when we got the new ICP, it came with the new Autosampler, so we just hooked it all up and ran it, and we stuck this in a corner because it's not bad, right? Those types of systems can be taken out of the closet or off of the shelf, hooked up with a dilution module, and made into a SimPrep, so made into a full sample preparation station. And that's a very... All right. So we talked about all of these many different functions and features of the system, and I want to come back to where we started, which was that we're talking about current laboratory challenges. So how does the SimPrep actually affect and health problems? So if you're having trouble with staffing or you're having trouble with social distancing, adding automation like the SimPrep allows more tasks simultaneously without additional staff, right? And it's like how this little diagram on the left will just keep running while I talk about other things. It does its job. That's just like the SimPrep, right? You set it up, you get it going, and you can walk away and do other things, and it will do its job, right? It takes care of that. So normally a typical rack of 60 samples takes about a half an hour to prep, and that depends on the specifics of your preparation, but that's fairly typical. It's around a half an hour, which is conveniently generally about the right amount of time to warm up your analyzer and prepare your sequences, right? So you get the SimPrep going, then you go get your ICP warming up, get your sequence file built. By the time you're done with that work, your preparation will be pretty close. And maybe what you do then is, all right, now I pour up the next set of samples. So as soon as these ones are done diluting, I put on the next rack, I get those going, then I put those on the ICP, right? And the really nice thing about it is you no longer have to have someone else do more. It helps to improve lab efficiency, helps to get the work done without having as many people in the same place, because you can have a robot do the robot work, and really it frees up your lab staff for work that uses their brains and not just their hand. What we want to do with better automation, and particularly with the SimPrep, is let chemists be chemists and let robots do the repetitive work, right? Lastly, pipette tips. Are you having trouble sourcing pipette tips? I know we are. Or you're just tired of paying for them because the costs have gone up. The SimPrep precision syringes remove the need for costly and possibly difficult to obtain pipette tips. So this may be something that's like in your SOP that we always use and suddenly we can't get. And I know there's a lot of labs that are struggling with pipette tips, and the SimPrep can remove the need for them. In places like biochemistry where I studied, we couldn't begin to use something like SimPrep because we were concerned about DNA level contamination. But for most analytical work, the rinse that you get from the sample probe is more than sufficient for what you need. And thus the carryover numbers that we looked at earlier, right? So switching over to something like the SimPrep, using its precision syringes to deliver the volumes accurately, because that's what you really need from your pipette, right? That allows you to lower your consumable costs and produce less plastic waste. And you can potentially, maybe if not completely, but at least partially cut a total consumable from your purchasing needs. But also automating that liquid transfer step removes an opportunity for error. I know I mentioned this before, but it's so easy to accidentally pipette into the wrong sample tube. Either to pull out of one you've already pulled from, or to dispense into one you've already dispensed into, or to just be, off. And it just, one tube over, they all look the same. It's so easy to do. So automating that really does, it removes an opportunity for error, and it's a very common one. In closing, I want to do a little summary here. So SimPrep really does help laboratories. It helps them to automate tedious sample preparation steps, right? If you can take away those the daily mind-numbing steps like that, where you're just pipetting, just transferring liquid from one place to another, right? That frees up your staff for more important and more critical tasks, which leads to better job satisfaction because they're doing something where they actually have to engage a little bit more, and where what they're doing really matters more than if they're just moving liquid from point A to point B. You can also reduce your consumable usage. And as we mentioned, there's some nice features like using one Autosampler for both sample preparation and sample introduction. You have plug and play installation. This thing is user installable. It's very easy to do. We have an install video also up on our website that you can go and take a look at. It's about 7 minutes long, and it walks you through the whole process. It's got very intuitive software, and it comes with some example methods to kind of get you up and running. And then finally, it helps to unify and improve your sample and standard preparation. By unify, I mean, even in good laboratories, even when your technicians get along, person A versus B versus C versus D, they're all going to prepare the samples a little bit differently. And you can see that in your data if you're looking for it, right? So you have your SOPs and they help, but using something that's automated like that, like the SimPrep, is really going to help get an overall unification of your sample preparation step and make it just generally reliable. And then it's a lot easier to do this sort of repetitive work every single day. All right, so with that, I want to go ahead and close. I want to say thank you so much for your time. Thank you for attending. And we're going to go ahead and close this webinar. This is being recorded, so it will be available later. If you know anyone who'd like to learn more about the SimPrep, please feel free to reach out to me or to our marketing group. We're always happy to answer questions. And once again, thank you so much.